Hi, everyone. Great to see you again. Coming to you in this broadcast from a bit of a grey and cold Melbourne day, I'm afraid. So I hope wherever you are, it's really nice. And again, today we're going to be looking at the back to the fundamentals of software development, the axioms as they're called. Um, and this has been a great series. We've had two previous videos on this. We've looked at the first of those up to number 7. And today we're going to finish those off. So 8, 9, 10, and 11. And the reason we're looking at these axioms is because the axioms really are the fundamentals of all software development. They are those things that if you do them and you do them correctly and you follow them regardless, you will have a successful software project. I mean, there's all sorts of other factors that come into it, but these are the fundamentals. This is the bedrock that supports all of your application development, and that's why it's so important. So obviously, there's a lot to go through with these, and I'm trying to get through them in a very short webinar. I don't want anyone to to miss anything that I'm saying here, because obviously there is a lot to say. So I want to go through them as rapidly as I can, but I would like anybody, if you have questions, please get back to me. You can contact me directly on Twitter at Reinteractive, or you can go through our website inquiry form and send me an email. If you're watching this on YouTube, just leave a comment on the YouTube channel and I will definitely get back to you. And I'm happy to speak to anybody at any time. If you've got my phone number, of course, just give me a call. So let's have a look at these fundamentals. So, just obviously going through the slides, we have discussed a lot of these already. And when we look at these axioms, again, I just want to reiterate, these are fundamental to everything. These are the basics that we look at all development on. These are the fundamentals that at Reinteractive we make sure we follow quite religiously. And in doing so, we have, highly successful projects. All right, so I just want to recap a couple of the ones that we already went over. The first two are probably the most important, which are desired features always exceed available budget. Now, this is one of those ones that, people tend to miss a little bit, and it's number one for a really good reason. When you start a software project, you want to try to get everything done. You want to try to all of your features, all of the ideas that you had, you want to try to build straight away. And inevitably, 100% of the time, your budget won't cover all of those. And it's never a good idea to build all those features anyway, because quite honestly, whilst you might think they're a good idea, are they really what your target market actually wants? So you try to get back to a small number of features that are actually going to be the ones that are needed, those minimum set of products, the MVP, deliver those, and then iterate on that. Number 2, communication is king. Underlies everything we're going to talk about. If you have good, solid communication between sales and client and developer, project manager, stakeholders, and eventual users, communication is so important amongst all of those. Going on, so the second webinar we looked at numbers 3 to 7. Number 3, always consider the return. Don't build something, especially initially, if you aren't sure that it's actually going to return something to you. In most cases, to be very obvious about it, that's monetary. So try to build the things that are going to return the most first. Number 4, design, validate, build at every single step that you do. You do some design work, you validate that by giving it to the stakeholders, the eventual users, some people that can go, oh, yep, this is actually right, this is what it should be, and then you build it. You do that process over and over and over again. If you do that correctly, design, validate, build, you won't end up with too much in the build that you didn't actually need. Inevitably, there'll be a little bit, but you still go through that design, validate, build process, even on small pieces of work. Just keep doing it. Number 5, be ready to go live. So as rapidly as you can when you start a project, get things into a state that can go live. And it might be live with absolutely minimum amount. You might be building an e-commerce store and all you've got is the products ready. Get that live, send it out there. So at least people can start looking at the products, then build the cart very rapidly after that. So as people are starting to look at it, you've now got the cart going live and you can start to find things that are going wrong, or you can find things that people really like. Be ready to go live. Number 6, ownership and accountability. For a client, I always tell them you have to have someone in your organization, someone in your business, someone in your group who can take complete ownership of the application that's being built. They're going to be the primary person to do all the testing, which we'll talk about more in a minute. They're going to be the person that's going to be able to present it to everyone else in the team. They're the person that's going to be able to make decisions on it. Yes, this is the right color. No, I don't like the way this flows. Let's make it do something different over here. Here's a feature we didn't think of. I need it added in. Complete ownership. It goes for the developer. The developer has to have complete ownership and accountability. If something goes wrong and it doesn't work correctly, the developer has to be able to say, you know what, I didn't do that correctly. I'm going to fix that. So everybody, whoever the stakeholder is, has to have complete ownership and accountability. And number 7 is prefer stability over features. We're going to go into a little bit about maintenance and testing and so on, but prefer stability over features. Do the work to make sure the small set of features that you do have actually work and deliver what they're supposed to and are stable and fast. More important than building lots and lots of features. If you have lots of features and they don't work correctly, no one's coming back to your application. If you have a small set of features that work really well and a promise of more in the future, people definitely are going to come back. All right, here's some new ones now. Number 8, stick to your knitting. I know that's a bit of an idiom, but it's this. Do what you're good at and what you know best. Don't try to do things that aren't your field of expertise. And this is such an important thing. It means when you're building a piece of software, we always at Reinteractive try to grab pieces of code that are already tried and tested, that we know already work. And that could be something as obvious as your payment processor. We're going to use Stripe, or we're going to use PayPal, or we're going to use eWay, or whoever it might be. But we know they already work. We know they've done all of the testing. They know all of their compliance is correct. So we're going to connect to them, and that's who people are going to pay through. We're not going to try to build an entire payment processor. Why not? Because they're complicated things to build. If we're building you a piece of e-commerce software, or we're building you an appointment booking application, we're not going to try to redo those things that have already been done. Why do that? Hundreds of hours of work. We don't know all of the edge cases. We don't know all of the strange things that might be run into. What we are going to do is build the things that are proprietary to you, those things that are your great ideas that no one else has done before or no one else has done in the same way as you. They're the things we're going to build, and we're going to build those really well. When we're using the programming language that we use at Reinteractive, that is Ruby on Rails, and other programming languages are similar in this, there's entire libraries of code that have already been written, already been tested, already kept up to date. So we just have to plug those in and use those rather than rebuilding them every time. And for sure, as a hobby, or maybe on your spare time, or maybe you want to do some open source work, for sure, get into that other stuff. But when we're building something for a client, we're always going to find things that have already been built as a fundamental, as a basis for what we're doing. All right, number 9, test adequately. This is one that's missed very, very often. I see very, very large applications all the time without correct testing. Now, testing, when we talk about this, testing means doing things that are going to make sure that your code actually works. It's part of that validate step that I talked to you about earlier. So when somebody's written a piece of code, we like to test it to make sure that it does what it's supposed to do, that there's no obvious errors in it, that there's nothing that's going to break. So that's testing. But how can we do testing? You've got a very large application. There's all sorts of ways that a user might use that. Now, a person can sit at a computer and put in lots of inputs and try to do as much as they can manually. But honestly, that takes a really, really long time. So what we do is we build automated tests. So as soon as a developer has written a piece of code, he writes another small thing called a test, which is going to simulate inputs into it. So let's say we have a login form, as an example. It needs an email address, needs a password, and maybe there's a checkbox to say, remember me, and a button that says go. So we can test that by setting up a little program off to the side that puts in that email address, puts in a password, and we can try to do it with a correct password. We could try to do it with a wrong password. We could try to do it with a correctly formatted email address. We could try it with an email address with a space at the front or a space in the middle where it shouldn't be. We could try it by putting all sorts of strange and unusual things in there, things that maybe you think might be used, but actually you'll find a user that's going to do that. And so we do all of that. And that means then that every time we do a little bit of development work on this piece of software in the future, we're going to run that test automatically. We just go test. We write the word test into a thing and it runs these tests. And it's going to check that form. Now, what might happen is in the future, someone writes a piece of code for another thing, but unknown to them, it breaks the form that they didn't work on, but it does something. There's some piece of interrelated code or something in the database that's connected to that. And because of that, this form doesn't work anymore. But if we run that test, it'll pick it up. So that's why this automated testing is really, really good. So what do we test then? Because again, it's really difficult to test 100% of your application. In fact, probably impossible because you don't know every single thing that's ever going to happen. And you can spend too much time writing tests as well. So what do we test? Well, we test those algorithms, those things that are supposed to do a little bit of work in the background, like an input form, for example. And we test with numbers that are a little bit unusual. Say the expected input is a number between 1 and 10. Well, try it out by putting in a number of 1 billion. Try it out by putting some text in there. Try it out by putting a negative number in there. See what all those things are. See what happens there. So they're pretty easy to do because you can sort of do those range of things, put it into a test, package it off and go. What's a little bit harder is a feature. When I click this button, this box should open and this box should dance around on the screen. That's a little bit harder to test. We don't know everything that a user is going to do on the screen. We can do what we expect they're going to do, but we don't know everything. So what we then write a test for is what we call the happy path. That is the medium way through that we think most people are going to use. And there might then be a bug in a 0.1% of case. Okay, so that is one user that might have a poor experience, but everyone else is going to have a great experience. We know we've tested all of that. And ongoing work will pick up these other bugs and eventually, you smooth them out. Here's a piece of information that's really important, especially as the complexity of your program grows. There is no such thing as a piece of software that is 100% bug-free. And even if someone says they've tested everything that they can, I guarantee you're going to find a user that's going to do something that's going to produce a bug. Now, a bug for one person might not be a bug for another person. What somebody considers to be an incorrect way that it works. Here's a good example of that. Again, back to our login form, username, password, a button that says login now, and then there might be under that a checkbox that says remember me. Now, unfortunately, that sequence isn't actually an obvious sequence. You're going to use the first two input forms first, the username and the password, and then you're going to click the button. And as you click the button, you go, oh God, I want it to remember me. But that was fourth in the sequence, you see. So people didn't see that. So that might be considered a bug. That might be considered an incorrect use. It's not going to break the application, but it's just a poorer experience for the user. So in future iterations, we can put that checkbox before the login now button, and that's a fixed thing. But you can see that would be a little bit of a difficult thing to test. So this is why bugs are never 100% free. And in particular, as the complexity of your application grows, you'll find more and more of these things. And so you need to continue on with this sort of stuff. I'm going to go into this in a moment. In number 11, we're jumping ahead. All right. Here's something else that you need to know about testing. If you deliver lots and lots of features when you first start writing your application, as you can see here in the first graph, features delivered is on this axis and then time across the bottom. You can deliver lots and lots of features. As I said, you won't ever get these bug-free. So what's going to happen then is after you've built all these features, you're going to spend a lot of time fixing those bugs. And as you're fixing those bugs, you're not writing new features. So a more desirable thing is a smaller number of features. Means that there's less bug fixing to do, bug squashing as we call it. and you can start to write more features. And as you're writing those features, of course, there's more bugs that have to be fixed and so on. But it's smarter to write a smaller number of features. And you've seen that from some of the earlier axioms. Don't try to build everything at once. Build a smaller set, and then you can write more into the future. And your users will keep coming back because they'll go, okay, I want to see more. I want to see more. And if there's less bugs, they're going to be happier to come back. You see how these axioms start to tie in together. Axiom number 10, automation builds productivity. What is automation? Automation is anything that makes a process happen in a particular sequence and in a particular way that doesn't need a user input. So you might put a bunch of variables in at the start and you'll get an expected output at the end, and all the stuff in between you don't really have to think about. So we just discussed that in terms of testing. Writing these tests that happen in the background is actually an example of automation. Okay, so you have to automate where it's possible to automate. So automation requires that you have an understanding of exactly what has to happen in that sequence. It's no good trying to automate something if there's some user decisions that have to happen in the middle that stop the automation process. It actually doesn't work because you might as well just do it by hand. The other thing about automation is if it's a simple process, don't spend a lot of time building out that automation. That's not going to actually save you any time in the end. So, programmers, because they're so good at programming, often like to program these automations that happen. And it's not always the smart way to go. It's not always the best way to go. Sometimes things can just happen as well, and somebody does them and it's okay. So here's some things that are good for automation, and you should absolutely use where possible because it increases your productivity. It means that things are more productive. So tests, as we just discussed. Deployment is another one. Deployment means moving the code from where it is on your developer's computer into what's called a staging environment where it can be tested by a wider group of people, and then once approved, from staging into the production environment. Now, we don't need someone to sit there as you might do on your computer and drag and drop files from one folder to another. And when I first started development 10, 15 or 12 years ago, I should say, that is what I did because I didn't know any better and because there probably weren't better systems around at the time, to be honest. And because we now understand how this deployment process works, and it's got to be exactly the same every time. In fact, for the sanity of everyone involved, it has to be exactly the same. Things have to happen in exactly the right sequence. And if something goes wrong, it needs to be brought to the attention of somebody. And these automated tests that we were talking about, they can happen through the deployment process, and it has to be on time, and it has to happen in exactly the right way. So deployment needs to be automated. It's the only way it can work, as a matter of fact. There's things in development that we can automate. For example, when we discuss getting some of these application pieces that are already built, there's an automation to that because we don't have to think about it. We just plug it in. We don't have to know everything that's happening in that code library. We just have to know what the input is and what the expected output should be. And if those things are correct, then we can use that piece of code. That's as simple as that. We know it's already been tested. We know it's already relatively bug-free. We know the security's already patched, all of that sort of stuff. Excuse me. So in this way, you're saving time to do what's actually important, which is writing new pieces of code, which is doing the things which require some creativity and some thinking and some real work. At Reinteractive, we have a service called OpsCare. OpsCare is an example of a large amount of automation to make life a lot easier and simpler. OpsCare is a DevOps service specifically for Ruby on Rails clients on Heroku and on AWS. And we've built a bunch of tools that automate all sorts of things. They automate some of the scaling aspects. They automate the reporting that goes on. They automate setting off alarms when things go badly. They automate backups. They automate rollbacks. Here's a good example of that, actually. I'll give you an example because it's very, very topical. Several years ago now, the founder of Reinteractive, Michael Linzer, who wrote these axioms, these fundamentals that we're talking about today, he's a great developer. He's a fantastic developer, in fact. And one day he was writing a piece of code for one of his websites, a really, really simple piece of code. All it was a piece of code that updated the copyright year in the footer instead of hard coding it in. So it was, at the time, probably 2015 or something. Instead of saying copyright 2015, it was copyright insert current year, if you know what I mean. So he wrote that, he tested it, it worked, he pushed it to the live production site himself, and then he went off to dinner, left his phone at home. And unfortunately, there was a small syntax error. That means, something mistyped in what he had written. And the immediate test passed because it was not an obvious thing. It was something that would only come up in a certain circumstance. And I'm not sure what that circumstance was. But what happened is it actually crashed the entire website. So you've got this small little error in this piece of code that was written that crashed the whole thing. Of course, lots of people are phoning. No one can get through because his phone's down. So the ops care team, the DevOps team, finding that this has happened, finding that the website crashed, clicked on a button. It rolled back to the last good version, which was an hour earlier. The website's back up for everybody. The next day, Michael could come in and go, oh, what are all these phone calls and messages I got? Oh, whoops, fixed up the mistake, sent it live through to production with beta testing this time, and everyone was happy. So that's a good example. Another good example, and one that I love to tell people about, is the Model T cars. Most people sort of know this story. It's sort of a famous one. Model T was the first production line car. It was developed by, obviously, Ford, Henry Ford. Was it the best car around at the time? No, it definitely was not the best car. But it was the cheapest. And it was the cheapest because what Henry Ford had done is he'd worked out a production line. Cars are exactly the same one to the next, or should be. So you should be able to have 1,000 cars, let's say it's the Model T, and it should be impossible to tell the difference between each one of those cars. They need to be exactly the same. How do you make them exactly the same? You give one person one job to do. So this guy, his job is to bolt in the bolts that hold the tires in place to the axle. Another guy's job is to fit the cap onto this part of the engine. Another guy's job is to attach the steering wheel and make sure it turns. That's all. And one person doing one job means that thousands and thousands of cars can be produced really cheaply and exactly the same. So it's predictable. You know what's going to happen. And sure, these things might have broken down, and sure, they might have gone wrong from time to time, but because of the fact that they were all exactly the same, someone could fix them. And so the Ford factory was born. Someone else over here was one guy trying to build an entire car. And sure, he built a beautiful car. It was a fantastic car, but he could only build one. And so it was highly expensive. And he was probably the only guy that could fix it. So Model T really worked out this whole automation builds productivity. And of course, every car factory in the world now works on that philosophy and on that viewpoint, as does many types of manufacturing around the world. So this is not just something that applies to code development, as you can see. And the last axiom, number 11, maintenance is cheap. What is maintenance? Maintenance is anything that's going to keep your application in a state of repair. That is something that works. When we've built a piece of software, it's not like a bottle of wine. Bottles of wine, of course, improve. You put them in the cellar and they get better month to month, year to year. So when you pull them out in 5 years' time, they're much better than when you put them in there. I mean, that's the theory anyway. Now, unfortunately, pieces of software are like most other things in this universe. They degrade over time. Not because somebody did something wrong, and not because they were poorly built, or not because there is something inherently wrong with software. It's just part and parcel of life that things don't automatically get better over time. They're more likely to get worse. And they definitely do not stay the same. So they have to be maintained. Look at your piece of software more like your car. Cars are beautiful when you first buy them. They smell great. They work fantastically. There's no strange noises happening. When you put your foot down, they go, all the rest of it. And then after a while, you hear a strange sound. Well, what is that? Not really sure. It doesn't matter. Keep driving it. You're in the car park. Someone dings the door. They have parts that wear out. The tires need to be replaced and so on. And after a year, okay, you need to get it maintained. We've got to do the spark plugs. We've got to do the filters. We've got to do the oil. We've got to change your tires or rotate your tires. And as that car gets older and older, more and more of these things happen until eventually you go, why is this thing costing me thousands of dollars a year? So you have to maintain your car. And the better the maintenance you do on it, the cheaper that thing is at the end, where you go, why am I spending thousands of dollars? And you probably don't spend as much if you maintain it properly the whole way through. If you never get a service done on your car, expect things to go really badly. But if you do that maintenance every 6 months or every 12 months, you'll find that things get better. So we say the same thing about a piece of software. Keep it maintained. So at Reinteractive, we have a couple of services. The OpsCare one that I told you about to keep the infrastructure, that is the server, the hosting, all in maintain. And the other one is CodeCare, which keeps the code base itself in maintain. Here's some of the things that go wrong when you don't maintain your application. Data breaches. A data breach is someone gains access to your database, and they do it because something that you didn't think of when you were testing or wasn't even known. There was just some flaw in the database infrastructure on your code or something like that wasn't even known at the time. But some guy in his basement somewhere figured it out and now has access to your entire database, all of your usernames, all of the passwords, all of the credit card numbers, whatever it might be. So that's a data breach. Data loss, similar sort of thing. Someone rips off all the data, or they put it into a state where it can't be used. Performance slowdowns. These just happen because maybe the volume of data that's sitting in your application grows to a certain size. Maybe it's just the number of users using the site has just grown to a point where the infrastructure that you set up just doesn't track it anymore, and you need to increase that. There's various ways that the performance can slow down. Integration failures. This is actually a very, very common one, and one that happens all the time. Maybe you use Stripe on your application. Stripe makes some changes on their end, which require you to make changes on your end. And if you don't make the changes, you can't keep using the service. Well, if you don't know that you have to keep things in maintain, you might not realize that this is the thing. Someone goes to pay for something and they can't because Stripe no longer works on your application. This is a real life example. This actually happens. This is something that actually occurs. Stripe will send out an email. You better pay attention to that email because something needs to be done. Hijacking. Someone again gains access to your website and takes it over. It happens. It doesn't happen often. And the better your infrastructure and your code base is maintained, the less likely it is to happen. You'll be connected to other libraries of code, as we talked about. We wanted to try to automate things and make things life a little bit easier by using these code libraries that exist, similar to the integrations. Those code libraries stop being maintained sometimes, or breaches in them are not fixed up and patched, or they just stop being published. And so you've got some ancient version of this thing that can't be updated into the future. So you have to keep those in maintain as well. The last risk of not maintaining an application is morale, because all of those other points all add up to low morale amongst your developers, amongst your staff. Because if things are slow and they're not working, think of a laptop that you had once that, maybe you'd had it a few years and it just stopped working. It just decided, I'm going to pack it in now. This happens. Or it just starts to go really, really slow and some of the applications don't work and, it keeps popping up error messages all the time. This is poor morale. You're not happy about it. So keep things in maintain. So here's some of the things that need to be maintained. OpsCare, CodeCare, as I mentioned. Security needs absolutely crucial. Security patches. So the security means, fixing up those things where people could intrude. Are your database queries in good shape? Do they need to be fixed up? Are they too broad? That sort of stuff. Are they validating the data that's put into forms correctly? Are there some things that you need to add to that or take away from that? Patches, security patches, so they're things that are applied on top of what you already have to make things a little bit more secure. The database itself sometimes needs to be upgraded, needs to be fixed. There's dependencies, as we said, those libraries of other things. The infrastructure, keep an eye on it. Has your user base grown to such a size that you need to add more resources so it doesn't slow down all the time or even crash and go into errors? The documentation has to be kept up to date. Any piece of software has to have attached to it a bunch of documentation which explains how someone can set up the application, how they can deploy the application, any strange things that are happening in the application and things that should have been done that weren't. make sure it's all kept up to date. So the next developer who comes on can read that and go, okay, here's what I'm supposed to do. And all of those tests also need to be kept up to date. So it's no good just writing them when you first make the application. You have to keep updating those tests. Most programming languages these days are continually updated to not just fix all those security points, the stability points, all of those things that need to be, continually looked at, the speed of the application, all of those can be fixed by upgrading your versions. So make sure you keep an eye on that. The versions need to be updated, keep them in sync with the libraries, get the best out of what those libraries are. So these are all things that need to be done. All right, so maintenance is cheap. As it says here, the money you spend on maintenance is like an early payment on a loan. Those payments earn interest and return much bigger dividends into the future than the initial investment. Spend money on maintenance as you're going, and it's so much cheaper than having to do this massive amount of work later on. Okay, so just to cap this off here, applying these axioms, these fundamentals, result in successful application builds. You want a good piece of software, follow these. The other thing that I would say is when you're looking at building a piece of software, start the conversation as early as you can with your developer, with your project manager internally, working out the UX, all of these sorts of things, because these points that I discussed, whilst they might sound easy to talk about in a webinar like this, they can be difficult to bake into the whole process and the whole application of what you're doing. Like, how do you work out what that small set of features to launch actually is? So you want to start the conversation as early as possible and take everything into account. So that covers off the fundamentals here that we're talking about. I really hope that this was informative to everybody, this series of webinars. If you have any questions, please get on to me. Please have that conversation with me. I'm more than happy to, go over these again in any detail or try to work out how they apply to your specific case and your specific instance. So I hope you have a great day. I'll speak to you in our next webinar. Goodbye.